So let us talk about the basic rule of logarithmic. So there are a few things that we need to understand under logs, and this is what we call the basic rules of logs. If at all you have log base c, let's say base a of x to the power n, the property of log allows me to shift the power to be in front, so this becomes n log a of x. At the same time, I can shift this to go as the power. Another property is log base a of a is 1. So log of base itself is basically 1. Okay. Then another property that I want you to understand is that log, if there is no any base, it is in base c 10. Same applies to ln. Natural log of ln, it is always in base e. Okay. So then you should note that ln e, if the base is e, that is the same principle with this one. So the base of ln is always e, then the answer for this guy, it is just basically 1. Okay. Another property that we need to understand is regardless of any base, log 1 is 0. Same applies to ln, 0. So the answer for this guy and this guy is 0. These are the properties that you need to understand. Ln 0 is undefined, log 0 is undefined. Log negative is undefined, ln negative is also undefined. So the properties of ln and log, they are basically the same. We're just talking about the same logarithmic functions. So these are the basic rules that we're supposed to understand. Okay, now we can use these basic rules to evaluate what we have. Okay, so let us start with the first question. I mentioned to say log, if there is no any base, then it is in base what? It is in base 10. So I need to make the base and this guy to be the same, so that I should apply this law. So then I can say log 1 over 10 is basically the same as 10 to the power negative 1. After reaching at this point, I can now apply the first property. The property of log allows me to shift the power to be in front. So that becomes now negative log 10. This is log base 10 of 10 is 1. Negative 1 times 1, negative 1. That's the answer. Let us go ahead and look at question 2. Log, anything in the square root is the same as raised to the power half, in case you don't know. The property of log allows us to shift the power to come in front, so negative half log of 10. As long as the base has not been indicated, it is in base 10. Log base 10 of 10 is half. Done. So the answer there is half. Let us look at the last one, which is natural log of 1 over e to the power 3. It's basically the same principle. So it will be ln e. To remove this one, we want to make the base and what is inside to be the same. It will be negative e. So here, remember, there is an invisible e, that is the base. The property of log allows us to shift the power to be in front. That becomes this. Ln e is the same as this one, which is 1. So now negative 1 or negative 3 times negative 3 times 1 is negative 3. That becomes my answer. So that is the general idea behind this guy. But using the same concept, I want us to go ahead and also look at the certain question, that is this one. So we are going to use the same concept now to look at this one, which is question 6 in this case. So we are using the same properties. Okay, the property that we said, I'll just rewrite them here. We said log of a x to the power n is n log ax. We said log of base itself is 1. Same applies to ln, if at all you have got ln. Then another thing is which other properties were we talking about? We were also talking about if we have got log of 1, that is 0, then log of 0 is undefined. So these are the properties I want us to use. So ln is always in base e. Log, if they have not indicated the base, it is in base 10. Now if we look at the first one, it's just a matter of us making the base to be the same, okay, making the base to be the same as the so we're making the base to be the same as the what? We're making the base to be the same as this guy on top there. I've used the white color, but this one. So log base 2 of 3 to the power is 64. 64 can be written as 2 to the power 6. Not so. So log 2 to the power 2, the property of log allows me to shift the power to be in front. That becomes 6. So 6 log base 2 of 2 is 1. So 1 times 6, 6. Pause the video, try to solve part 2. If I go to this, it's basically the same thing that we have been doing so far. Log base 2 of 1 over 8, it can be written as log base 2 of 8 to the power negative 1. So log base 2 of 2 to the power negative 3. Negative 3 can come in front. So negative 3 is the answer. Now I'm going to look at, you can do the part 5, the one for 1 over 27. Send the answer in the comment section. I'll be able to see it. And then ln is basically the same of the one we are solving actually. So guys, go ahead and solve this one because it's basically the same as this one, the one I solved here. So go ahead and look at that. Okay. After looking at this, I want us to also look at how we convert the exponential to log at the same time, from log to exponential. So I'll give you a very simple example. Let's say we have got log x of y is equal to 2. So this is how we read log base 2 of y, not log x to the power y. No. Log base 2 of y is equal to that. So now we are going to look at this. I want you to understand that this is basically the same as x raised to the power 2 is equal to y. So the base raised to the power what is outside is equal to what is inside. Okay, interesting, right? Let's solve part 1. The base is 2. Put the base here. What is outside is 4 raised to the power 4 is equal to what is inside is 16, and this is true. 2 to the power 4 is 16. Interesting, right? If the base has not been indicated, then it is in base 10. So the base is 10 raised to the power what is in outside is equal to what is the inside. 2 to the power 2, 10 to the power 2 is indeed 100. This is always in base e. E raised to the power what is outside is 1, negative 1 is equal to 1 over e. E to the power negative 1, in short here we have converted, but we should know that these are the same. There is 1, you can remove 1 on top and put as negative. Let's try this one. E, that's the base, raised to the power what is outside is 3 is equal to x plus 2. Done. So that's how we convert now from exponential, from logs to exponential. But again, we can use the same concept. Okay, we can use the same concept again to answer this. So now here we are coming from exponential to log. So remember, I will just go back to this. I'll give you an example of the first question that we were looking at. So the first question we said it is 2 raised to the power 4 is equal to 16. So you can clearly see that log, you just write log, this is always the base 2. What is the power is what is outside. What is outside here is what is inside. I'll carry this and use it for the next question. So here, what this guy here is becomes the base. So this is always the base. Okay, then what is the power becomes what is outside. What is outside becomes in here, like that. So here, if I want to change again using that concept, it is 3 raised to the power 4 is equal to 81. I've gone back there. So it's basically the same thing. So here, if I want where there is e, I'm going to be using ln. Okay, so I'll say ln, the base, this becomes the base, so it is e. Okay, it is always in base e, that one we know. So it is always in base e, but it is invisible. I'm not going to include it. Y is equal to 4. If I want to convert this to exponential, I know that the invisible is base. The base is e raised to the power 4 is equal to y. Not so. Go ahead and look at that one now. This is going to be the same. Ln, e is not going to appear because that is invisible. We know that ln is always in base e. Then 5 will be here is equal to x. If I want to change again, it's e raised to the power x is equal to 5. Again, it's the same with that. Next, as long as there is e, you have to use ln. If there's no e, you use log. In this case, I'll say log. This is always the base. Now, if it is in base 10, we don't include the base. Okay, we don't include the base. So this will be equal to what is the power is what is outside. What is outside here is what is going to be inside, like that. If I want to change again, is 10 raised to the power this is equal to y. Interesting, right? Yeah, so pause the video, try to solve part 5, send me the answer in the comment section. I'll be able to see it. Yeah, so these are the basic rules that we're supposed to understand under log. Okay, let us go ahead and also look at how to express let us go ahead and look at how to express logs into single quantities. So there's some few things that we need to take note. If we have got log, the base is the same, log a plus log b, provided that the bases are the same, then you multiply what is inside. So it will be log a times b. So if I've got log a minus log b, provided that the bases are the same, then we can divide this. The part having positive will be on top, b will be down. So this is the principle that we're going to be using. Okay, but remember, these are supposed to be the same. Log in front, there should be nothing in front. Let's begin our discussion with the first one anyway. So this one, log, the base is the same, we can multiply. So the base is the same, then it's just telling us to say it is x squared times 1 over x. But x squared times 1 over x is the same as x squared divided by x. X squared is the same as x times x divided by, we have put this x down, so 1x can go. So therefore log will be, this is the single quantity. Now I've expressed it using the same concept. Pause the video, try the second one. So log base 3 of 9 plus, the property of log allows us to shift the power to become to the guy which is in front to become the power. So that becomes 2 to the power 3. So log 39 plus log the base is 3. Now this becomes 8. Provided that the base is the same, you rewrite this, then you multiply now this times that. So it's 9 times 8. It's not a point, guys, it's times. So 9 times 8 it should be 72, but I don't know. 1 2 3 4 5 6 7 8. Yeah, it's 72. So 72, that's the answer. If I look at the second one, the third one, try to pause the video, try to work it out, then we can clearly see that we have got log or ln y. The property of log allows us to shift this to become in front, or to become as a power. So it will be power 4 minus log 4. The bases are the same, so you write ln. The part having negative will be on the denominator, so that is the answer. This applies the same with what I have there. For them to have 1, remember the properties that we have been doing so far. Remember, for them to have 1, then it was ln e. So that's what we need to know. So it is the same as 2 ln 6 minus ln e. Ln e is 1. So I'll shift the power, this guy, to become the power 6 to the power 2 minus ln e. So ln 36, because 2 to the power that is that, so ln e. So here ln e. Now that the bases are the same, we'll just say ln, the power is invisible. Now that the base are the same, then this 36 will be on top. I will divide here by e. So then I have changed now to a single quantity. So this is the basic idea behind expressing log into the single quantity. Okay, let us look at change of base formula. So how do we tend to change the base? So I'll start with the, so the formula goes like this. If we have log a of b and we want to change this to base c, so you write log, write this b here, divide it by log, write this a here, and I want to change this to base c, then you just put c there. So I've changed from log base a to base c. Simple, right? Using the same formula, the question here they are saying use the change of the base formula to prove the following statement. So here we are proving that this is equal to that, so we are going to start with this part. So I'll just write log using the formula. Okay, I'll write the first one is a, then I divide log, then b. Now you look at what you are trying to prove. Now they are changing this to base a, so you put a here, a. Remember, log base a of a, log of base itself is 1. So therefore the top part becomes 1, the down part becomes like that. So this is exactly as that. Okay. Now let us also look at this. They are saying that show that that is equal to this. Remember, log and ln and natural log, they are basically the same. So here they have just changed this to ln. So what we should remember is that the formula remains the same. So here the base is 10. So you are writing log. So instead of writing log, we are going to use ln. So we'll say ln. Now we'll leave a space and put e. Okay, we'll put e. So now here they are changing to base e. Then you divide it. Then here you put also ln. The base here is 10. So you are changing to ln. Ln is always, you are changing it to base e. So you put e, you put e. So you can clearly see that ln e is 1. But ln e of 10, we don't know what that is. So we just put like that. So this is exactly as that one. Now I'm going to give you some more practice questions under this subtopic of changing of the base formula. Let's say we have we have log base 9 of 2. Let's change this to base 3. Pause the video, try to use the formula and come up with the answer. So log, you write 2, you leave a space, then log, you write 9, you leave a space. Remember, want to put base 3, put 3 here, put 3. Now the down part can be simplified further. Log base 3 of 2, 9 can be written as 3 to the power 2. The property of log allows us to shift the power to come in front. So what happens? We'll have log base 3 of 2 on top, then 2 log 3 of 3. Log base 3 of 3 is 1. So this simplifies further to be 2 times 1, which is just 2. But this can be written as 1 over 2 log base 3 of 3 over 2. Oh, can be written as this is log base 3 of 2. Why am I writing it in this way? If you have got x plus 1 divided by 2, it's the same as 1 over 2, then x plus 1. It's basically the same thing. Now it will not end there. The property of log allows us to shift the power, what is in front, to be the power. So this goes further, and it's going to be like this. When something is raised to the power half, it's the same as the square root. So I've changed now from base 9 to base 3. If you have gotten that, can you go ahead and solve this? Log base 8 of 9, change this to base 2. Another one which I'm going to give you is log base 27 of 4, change this to base 3. So go ahead and do this. Type the answer in the comment section. I'll be able to see them.